Alright, for the second part here, section 2.4 for the video here, we have example 3, where we need to find, from this frequency distribution, find the sample mean and sample standard deviation. So in this case, I would give you the frequency distribution. So for instance, I'd give you the class, and I'd give you the frequency here. And then you would need to fill out the rest of the information in the tables that I have here. So here, for instance, down here we have the sample size, which is also found by adding up our frequencies. So in this case, since we don't have a list of values to begin with, what we need to do is add up our frequencies to figure out how many we had to begin with. So if we add those up, we have 42 as our sample size for our n. So the sum of the frequencies is the same thing as your sample size, which gives you 42. So a lot of these terms also have symbols along with them. Some of them have more than one symbol depending on how they're being used. And then here in this next column we have the midpoint. So remember, to find the midpoint, you do your lower class limit plus the upper class limit, add those together first, and then divide by 2. So it's like finding the average of that interval is another way of thinking of it. So we get 4.5 there for the first midpoint. Next one, if you do the same sort of thing, you get 14.5, 24.5, and then 34.5. All of those, if you do it correctly, should be 10 apart from each other. Because if you look at your classes, each of those have a class width of 10. They're all 10 apart. So that would be for your midpoints. Those are also your x's in this case. So for our values in this case, instead of listing out all 42 values and having to do the stuff like we did in example 1, for 42 numbers instead of just 4 or 5 numbers, we're doing it this way. So it'll be a much shorter process rather than having to do it for 42 numbers. And then we do the x times f here, which x are our midpoints, times the frequencies. So here we do 4.5 times 12 to get 54, 15 times the 14.5 to get 217.5, 10 times 24.5 to get 245, and 5 times 34.5 to get 172.5. And then we add that column up once again, add up that column, and we get 689. So we use that then for calculating our mean here. So instead of adding up all 42 numbers that we might have for our set, we're doing this shortcut method. It might be a little bit different than you're used to, but it ends up being a lot shorter than having to do it for 42 different values. So once again, this is from finding the sum of that x times f column, and then dividing by n. So remember that n there is your sample size, how many values we had there to begin with. So we had 42 values, since that's what our sum of our frequencies is. So that means that's how many values we had to begin with. So on the top here, we have the 689 that we already calculated, divided by 42, how many values we had all together. And then you would divide those. So for our mean here, looks like you should get 16.405 for the mean there. Which, if you're doing the mean correctly, it should definitely be between your numbers somewhere. Somewhere between 0 and 39, otherwise you did something wrong. If it's something above that or below that, you did something wrong. It should definitely be between those values. So that's for this first part, for finding the sample mean. Once you have the sample mean, we can then go about finding our sample standard deviation. So it's similar, once again, to what we did in example 1, where we do our deviation, we do our value minus the mean, and then square it. So once again, this column here would be optional. You could definitely go through and then just do the subtraction and square it all in one step as well. So once again, you're using the values that we had to begin with, those midpoints, the 4.5, 14.5, and so on in that column. And you're subtracting each of those from the 16.405 to get that first value in the column. And then you're squaring those. So for instance, if we do 11.905 and square that, we get 141.729. And then if we follow along in that first row there, we then multiply by the frequency for the first row. So the frequency for the first row was 12. So if we do 141.729 times 12, we should get 1700.748 there. Same sort of thing for the other rows. You do your midpoint value, the 14.5 was the next one, minus the mean of 16.405 to get negative 1.905. Square that to get the 3.629. And then multiply by the frequency for that row. The frequency for the second row was 15. So you do the 3.629 times 15 to get the 54.435. And then do same sort of steps for the other two rows. So the extra column that we have here that we didn't have to do in example 1 was that column where we have the x minus our mean squared, but then times the frequencies. So the reason why we need to do that part times the frequencies this time is because we're dealing with this frequency distribution. Otherwise, you're accounting for all of those weighted the same, whereas some of those values we have more of than other ones. So you want to make sure that you are accounting for that whenever you're calculating that standard deviation. For some reason, my Microsoft Word is acting up again, so I'll wait here a second. Just a reminder, that final column there, you'll notice from example 1 to example 3 was different. So instead of ending with the squares column, we end with the squares times our frequencies. And then it'll be that final column there once again that we will add up to then get to our variance. And then from our variance, we go to our standard deviation. So from this step, will be very similar to what we had in example 1 for finding our standard deviation. So when we add those up here, for that last column, looks like we should get 4047.613 for doing that squares column times our frequency. And you do want to make sure whenever you're doing this that you're also double checking. See if you get the same answer, just in case I had a calculation error somewhere. So we had s squared is equal to, so remember s squared is your variance. So you do that 4047 that we had there, 0.613, divided by 41. So remember, for finding your variance, this is always your n minus 1. Because we're dealing with a sample standard deviation once again and a sample variance. So if we divide that out here, looks like I get about 98.722. Remember, once again, go out at least 2 decimal places. You can always go out more. So that would be for the variance. For the standard deviation, remember you then do the square root of what you got for your variance. So you do the square root of that 98.722. And then if we do the square root of that 98.722, looks like we should get 9.936. sure why it keeps lagging here tonight. Normally it records a little bit better than this. I'll rewrite those numbers once again here, make it a little bit more clear. A bit easier to read. So your final answer for the standard deviation part, once again, was 9.936 here. So you had two answers that I was looking for this type of problem. That's your standard deviation, the 9.936, and then the 16.405. So again, like normal, if you do questions, make sure you're asking either in class or during my office hours sometime before we have a quiz or test.